Okay. Number 15 from the Unit 1 review handout is graphing absolute value inequalities on the XY axes, or on the XY plane. So I'm going to do A and B two different ways. Let's see. For A, I'll just do it in the more direct way, and in B, I'll do kind of like step-by-step transformations instead. Mainly because that way will come in handy later on. On the quiz, you can use whatever you like, right? As long as you're using a valid method. So in the first one, what I'm going to do first is, in either case, I'm going to graph the boundary line, which is the equals version. And in this case, you notice the boundary line here is going to be solid because it's got that equals solid boundary line. The boundary line has the absolute value function form that we've studied. And so up here, we've got our vertex, the HK is 2, 1. And the A value is negative 1/2, and that's related to the slope, right? Since it's negative, so since A is negative, we know that it opens downwards, okay? And we know that one side is going to have a slope of negative 1/2. That's got to be the side going downhill, so slope is negative 1/2. And the other side, the slope is 1/2. So that's all we really need to plot this whole thing. So let me just make some axes here. So here's a y-axis and an x-axis. And I will plot the point 2, 1. Here's 2, 1. And then I've got a slope of 1/2. So rise is 1, run is 2. So down 1 over 2. Down 1 over 2, down 1 over 2, and then same deal on the other side. Down 1 over 2, down 1 over 2, and then I can connect them. Remembering it's solid because it was less than and equal to, right? It has both. So that does not show up well. Okay. And then I need to do some shading. So in order to shade, because it's an inequality, I got to pick a test point. I can't pick 0, 0 because that's already on the graph, it looks like. So I want to pick something that's obviously not on the graph. So instead of 2, 1, I'll pick 2, 0, right? So if I plug in 2, 0, we're going to test that in the original. So it's 0 is less than or equal to negative 1/2, 2 minus 2 plus 1. That 0 is less than or equal to, and then this whole thing turns into a big old 0 plus 1. And that's true. So this is the side that I want to shade. There we go. Okay, so that's A. For B, I'm going to do this in a more convoluted way, to be perfectly honest. It's not as efficient, right? But it's something that helps show how you get it from the parent function. So it uses these transformations, which I think is useful in thinking about functions, especially when they get more complicated. So for this one, the parent function is y equals the absolute value of x. So I'm going to make a brief chart here, x, y. I'm going to put 0, 0 in the middle because that's the vertex. And then I'll pick a couple negatives and a couple positives to use. And so this turns into, when it's absolute value of x, I just get rid of all the negatives and they become positives. And then the next thing I'm going to do, by the way, this is all related. This is just graph boundary line first. And so that's going to be y equals negative 2, x plus 1 plus 3. It's just the related equation. Okay, so the first thing that I want to do is this part of the equation, that negative 2. So I'm going to turn absolute value of x into negative 2 times absolute value of x. And the negative 2, it represents a couple things. So the 2 is a vertical stretch by factor 2. And the negative is a reflection across the y-axis. Because if you think about it, if you had a graph that looked like this first, and that's y equals absolute value of x, for example, and then I say, now throw a negative in front, all that really does is it takes all the y values and made them negative. So instead of a positive y up here, you now have a negative y. And so this one would be negative y, whatever this is, that's down here now. And you end up with the picture just flipped over. Okay, so throwing a negative in front flips it over. That's a reflection across the x-axis. I don't know if I said the wrong axis earlier, but it switches the y's, which bounces it over that horizontal axis. Now, the way that gets represented in the chart is, okay, you're taking the y's and doubling them. So multiply all the y's by 2, and then the reflection is the negative 2. That's how it becomes negative. So in our new chart, x, y, the x's didn't change at all. I didn't do anything to the x's, but the y's all got multiplied by negative 2. So now this is negative 4 because originally it was 2. Now this 1 gets multiplied by negative 2. This times negative 2 is still 0. This times negative 2 is negative 2. And this times negative 2 is negative 4. Okay, now there's one last thing to do, or two last things in a way. We got to account for the plus 1 and the plus 3. So you might remember the plus 1 being shifted left. So let me use a different color. Shift left 1. You might remember it like it's kind of feels backwards, right? It's x minus negative 8, or x minus negative 1 there. That's how you have to think about the x's. It's x minus h. And we're going to shift the plus 3. The y's feel a little more natural. We're taking the y values and tacking 3 more on, so it's up 3. So this means subtract 1 from x and add 3 to y's. So then in our new chart, x, y, this is now for y equals negative 2, x plus 1, plus 3. This is the x's all got 1 subtracted from, so instead of negative 2, it's negative 3. So they all went down by 1. 2 minus 1 is 1. And then I got to take all my y's and add 3 to them. So that becomes negative 1, 1, 3, 1, and negative 1. And these are my points on the graph. This used to be my vertex. That turned into this, which turned into this. This is my new vertex. Okay. So if I plot negative 1, 3, let's see here. I'll just put it right here. So negative 1, 1, 2, 3. There's my vertex. If I plot negative 2, 1, that's right here. Negative 3, negative 1, right there. And then over here, I've got the mirror image stuff. 0, 1. Whoop, 0, 1. And this point right here, 1, negative 1. There is your absolute value graph. Okay, so I just realized I ended the last video. I'm trying to splice these together. We didn't actually shade yet. We only graphed the boundary line. So to shade it, I'm going to just pick a test point. 0, 0 is it's underneath that V shape. So I'm going to test 0, 0. And if we plug it in, we get 0. We're testing in the original now. Is 0 greater than negative 2 times absolute value 0 plus 1 plus 3. So is 0 bigger than negative 2 times 1 plus 3? Is 0 bigger than 1? No, that's false. So I'm shading everything above, up here. Okay, there we go. All right.